Solving a two-step equation with signed fractions. Remember, when we solve equations, you're trying to find the missing value for the variable that makes this original equation true. The other thing you want to remember is that when you're solving equations, every line of your work will also be an equation. Let's illustrate this. First thing you want to do with this equation is you want to find a number that balances this equation and that number will also get rid of those fractions. What would that number be? Well, we need the least common multiple of 2, 4, and 8. By inspection here, we'll realize that number is actually 8. So let's take 8 and multiply the entire left-hand side. There it is. And we'll do the same thing to the right-hand side as well, the right-hand side of the equation. And we need 8. Now we're going to take advantage of the distributive property on the left-hand side of the equation. And when you do that, something magical seems to happen. That is, when you take 8 distributed to negative 7 over 2, well, first do 8 divided by 2, which is 4 in the numerator. So 4 times negative 7 in the numerator is simply negative 28. And notice y is in the numerator as well. So this becomes negative 28y. You're going to have to distribute that 8 to the 9/4 as well. So distribute this 8 to the 9/4. Once again, do 8 divided by 4 first. That reduces to 2 in the numerator, and that becomes 2 times 9, which is 18. Wow. Notice the denominators are all 1. What's on the right-hand side of this equation? Simply negative 1, because 8 over 8 reduces to 1. If I'm doing this, and if it looks like I'm going too fast, you could write it out like this. You could write 8 over 1 times negative 7 over 2, and then reduce off to the side on your piece of scratch paper. And then notice that does look like what? Negative 28 over 1, which simply is negative 28. Let's continue. Notice you've written an equivalent equation that looks much simpler. So let's subtract 18 from the entire sides. And notice your new equation is negative 28 times y is equal to negative 19. Divide the entire sides by negative 28. Now your final equation says y is equal to 19 over 28. 19 is a prime number, so this is a reduced fraction. Notice your answer is an equation. How about the second problem here? We want to solve this equation. We want to find the missing value for w that makes this original equation true. First thing we want to do is balance this equation in such a way that we do not have to work with fractions. So what is the least common multiple between 3, 7, and 6? That answer is 42. We're going to take 42 and multiply the entire sides by 42. So over here we have negative 4/3 minus 5/7 times w is now equal to what? 42 times 1/6. Once again, on the left-hand side of this equation, we're going to use the distributive property. And then we'll see what the next equation looks like. Distribute the 42 to the negative 4/3, and distribute the 42 to the negative 5/7 w. Well, do 42 over 3 first. That'll give you 14, and then do 14 times 4. So 14 times 4, it looks like 76. Now, if you're not sure, you can always go off to the side and use a little bit of scratch paper. Oh, and it's a good thing I did. It's actually 56. So our next equation is negative 56 minus 6 times 5, which is negative 30w, is now equal to 7. Wow. Notice there are no fractions in this new equation. The other thing you want to notice is that your equal signs are all lined up when you're writing all these new equations. You're simply writing a new balance for every line of work you're doing. Let's add 56 to both sides. Now we have negative 30w. Notice the equal sign is once again below the previous equal sign. And now we have 63. Divide the entire sides by negative 30. And we have w is equal to, looks like 21 over negative 10. Now that is reduced. There are no common factors between 21 and 10, so that will be our final answer.